action.
We live. Hey, everybody.
Sup, guys?
We are here today to graph a quadratic function with all of you.
Quadratic, meaning the highest exponent or power is a 2. Looking out for that x squared.
Oh, and if the highest power is a 2, the shape of the graph will be a U.
We should all be familiar with that by now.
Mm-hmm. So if we're going to graph this quadratic parabola, we know that we need this turning point right here, which is the vertex. And then we probably should get 2 points on each side since it's symmetric.
Yep.
But Mrs. Long, how would we find the vertex? Because I typed this into y equals already, right? I put it there. And then I pressed zoom 6 to look at my graph. And I see it. And I could kind of sketch it here, but I know I need exact points. But when I go to my table, it's like a whole bunch of numbers here. And I'm not really sure where to start.
Well, lucky for us, there's a formula.
What is it?
Well, the formula is actually to find the axis of symmetry. And it's going to be x equal to, because it's the axis of symmetry, x equal to negative b over 2a.
And I'm going to guess that those letters, the A and the B, we found A, B, and C when we were doing the reverse box method. So is it those same A, B, and C's?
Sure is. A would be the coefficient in front of the x squared. B would be the coefficient in front of the x. And C would be your constant. Don't forget your signs there. Nice work, Mrs. V. -2, -3. So we're going to turn that into x equals negative b, and make sure you keep your parentheses, because when you have a double negative, some crazy things happen, and you don't want to lose that.
And then A is +1.
Yep.
And this is a fraction. I could probably use my calculator, right?
You could. I would, just because you got that
alpha y equals thing.
Negative thing, which is a little scary.
And then 2 parentheses. Oh, no. 1. Oh. So x equals 1.
So now we know that fancy imaginable line that cuts your parabola in half is x equal to 1. But that doesn't give us the point of the vertex, Mrs. V.
Yeah, where does the vertex go? Like, I don't know if it goes up here or here or here or here or here. So I think I'm missing the y value.
Yikes. How will we find it?
So if I have an x and I'm trying to find y, I could probably plug it in.
Plug it in. Yeah, if you have the value of x, you could plug it in to find y, because it says y equals that whole thing.
So y equals, so this is going to be that value of 1, right? So I'm going to do 1 squared.
So you're plugging in that 1 for all the values of x, because you found x equals 1.
1 squared is just 1 times 1, so that means that's going to be 1. -2 times 1, -2. And then -3 at the end. Oh, that looks cool. 1 minus 2 minus 3.
1, 2, 3. It's -4.
It is 1 minus, I'm going to mess this up. So I'm going to come over here. 1 minus 2 minus 3. -4. I was going to say -6, so I'm glad I plugged that in. Okay, so now I have my vertex as 1, -4.
That's amazing. That means you can graph it Negative 1, negative
Well, now
4.
I need my other points, right? So now I guess if I go back to my table, how many points did you say I should graph?
At least 5.
Okay, so here's my vertex, 1, negative 4, and I should do 2 on each side. So 0, negative 3, and negative 1, 0.
Yeah.
Okay, and then the other side, there's my vertex, 2, negative 3, and 3, 0.
Now that is enough points to make you a U shape for you to sketch a graph of this parabola x squared minus 2x minus 3. Now make sure you put arrows on it because it continues to go up and up and up. Mrs. V, can you zoom in on that table really quick? Yeah, see, I just want to point out, if they watched our video from the other day, they would see that the 1, negative 4 right there is the turning point, right? And the turning point also has 2 other names. One we just found, which is called the vertex. But it is also known as the minimum because it's the absolute bottom in this case. But if we were to have a negative parabola, it would have been the maximum because it would be the top turning point. But what I wanted to point out was notice that with the 1, negative 4, if you look at the y values, they're mirror images of themselves. So you have the
negative 3.
And negative 3 on both sides. And then you have 0, 0 on both sides. And then you have 5, 5 on both sides. So let's say you did forget this awesome formula that we just taught you, which is x equals negative b over 2a. You could go to your table and see the turning point. Problem with that is that sometimes we don't have perfect quadratics and the turning point is a decimal and it's not going to be in your table. So that's why you need to know the formula. So don't forget it.
That would stink.
Yeah, don't forget it. So,
all right, so we have our quadratic, we graphed it, we have the vertex. This point here, what is this point called again?
Ooh, I didn't go over that one. I don't know it.
It's okay. I'm going to ask them that question in this ed puzzle. Their video is going to stop in just a second, and they're going to have to label it. I hope you guys labeled it the y-intercept because it's where we cross the y-axis.
Ooh.
And then the next question, this video is going to stop in just a second, and we're going to ask you what these points are called. Can you name those? Hopefully, you just labeled these as the x-intercepts.
Oh,
but they have 3 other names. You remember some of the other names, Mrs. Long?
I do. Maybe they were options. I don't know. Maybe they weren't.
Oh.
There's 4 names altogether. I know that much.
If you don't remember them, you should go back in and rewatch the lesson from the other week because they have 4 names and they're super important. Should we talk about domain and range?
Absolutely.
Let's do it. Domain. Domain is all of the x values.
Yeah, don't you remember how I remember domain? Because if my x is coming near me, I'm like, no way. Wow, I'm getting dizzy.
Right. So what are all of the x values that go with this graph? How wide is this graph going to get as it keeps going?
Well,
is it ever going to stop getting wider?
Well, it has arrows, so that's telling us that it's going on and on and on and on and on and on. Sky's the limit. It could keep going. And parabolas might look like they're not getting any fatter, but the fact is, the higher they go, the wider they get. So the domain could be anything. Could be any number. Could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, which means that it must go from negative infinity to beyond. I mean, positive infinity. Also known as all real numbers.
How about the range, the bottom to the top?
Well, in this case, it looks like our parabola has a bottom, which we discussed earlier, is also known as the minimum or the turning point. And that turning point there, the bottom of it, is at -4. So it must begin at -4, and those arrows indicate that it goes to infinity. You got it.
-4 gets a parenthesis or a bracket.
Well, it's included that point, so then it would get a bracket.
You're right, because it was right here.
No, that's a good point, Mrs. V. I forgot about those bracket things.
Love those brackets and those parentheses.
Brackets versus parentheses. Brackets means included, parentheses means not included. Oh, but do you think they remember why an infinity sign always gets a parenthesis?
Yeah, they definitely remember.
They'll
type it right now.
Let's throw in that question. Them. Yep, let's do it.
Okay, so I think we showed them how to graph a quadratic. The formula for axis of symmetry is x equals -b/2a. So make sure you identify a, b, and c. Plug them in, and then take that value and plug it in for x. And that shows you where your vertex is.
Yeah, very simple. Then we discussed domain and range, but you know what we didn't talk about yet? Remember when we did that roller coaster thing with graphing stories, like way back in the beginning of the year? Kingdaka! Yeah, what was happening there? We talked about where functions do this and that and this and that. So we need to talk about where this function is increasing versus decreasing. And I know that we've caught you on Delta Math with that before also. So if we just take a look at this U-shaped thing and pretend we were on a roller coaster, if you started there on the left where our sweet stick figure is, you're going down, which means this function is decreasing from where to where?
Well, I remember this is always measured by the x-axis. So he's going to keep going down until he or she hits the vertex. So really this axis of symmetry here is what kind of splits the graph in half. So I think it's going to stop it. I think he's going to stop decreasing at +1.
Definitely a +1.
But I guess he starts all the way over here, which is going to keep going. And
well, he's going to start at the beginning of the domain at that. So the beginning of our domain, we just have to look back and see what we wrote. Just
-infinity.
Keeps going, yeah. So it's from -infinity to 1 is where it's decreasing. And then at that turning point, we're going to start to go up, which would make it increasing from that same value of 1 to...
And then using your same trick to the other side of the domain, which is +infinity.
That's right. That looks good.
That looks good. All right, so we have taught you something new, how to find the axis of symmetry in graph a quadratic, but we've reviewed and refreshed domain and range and increasing, decreasing, and interval notation. It was a good day.
It's a lot of stuff on here, guys. A lot of juice.
Yeah, you might want to rewatch it, at least the beginning part about axis of symmetry. And just keep in mind that sometimes your quadratics can open upside down. So when you start plotting your points, when we ask you to graph a couple more, don't be don't be confused or concerned if your quadratic is opening and going down the other way.
Because that's a sad one. Which really just means it's a negative x squared, because negative makes me sad, and that's what my face looks like.
There we go.
Very nice. All right.
Okay, that's graphs of quadratics. That's where it all comes to a conclusion. Wait till what we show you next.
All right. Ta-ta for now.
Bye.